Ever wonder what makes your electronic devices function the way they do? Ever heard of a diode? Yes, a diode. That tiny component you probably didn't even know existed, yet it's a crucial part of many electronic devices we use every day. From your smartphone to your refrigerator, diodes are there silently doing their job, making our lives easier and our tech smarter. Intrigued? Stick around as we delve into the fascinating world of diodes. So, what exactly is a diode? Good question. To put it simply, a diode is a two-terminal electronic component, and it's a type of semiconductor device. Semiconductors are materials that have properties somewhere between a conductor like metal and an insulator like rubber. Now a diode is unique because it allows current to flow in one direction but not the other. Picture a one-way street but for electrical current. This is due to its structure. A diode is made up of two different types of semiconductors, P-type and N-type. The P-type semiconductor is created by introducing impurities into a silicon crystal that create an abundance of holes, or places where an electron could be. The N-type, on the other hand, has an abundance of electrons. When these two types are joined together, it forms a diode which allows for this one-way flow of current. Now that we know what a diode is, it's time to understand how it works. How does a small device like a diode control the flow of electricity? Let's break it down. To understand the workings of a diode, picture it as a gatekeeper. It holds the power to allow or stop the flow of electric current. This gatekeeper is pretty strict with its rules. When voltage is applied in the forward direction, that is, when the positive side of the battery is connected to the anode and the negative side to the cathode, the gate opens. The diode allows the current to flow freely. But what happens when we switch things up? If we connect the positive side of the battery to the cathode and the negative side to the anode, or in other words, apply voltage in the reverse direction, our gatekeeper shuts the gate. No current is allowed to pass through. The diode effectively blocks the flow of electricity. But where does this gatekeeping action happen? That's where we introduce the concept of the depletion region. This region acts as a barrier when we apply voltage in the reverse direction. It widens, preventing any current from crossing over. However, when voltage is applied in the forward direction, this region shrinks, allowing the current to flow through. So, that's the magic of the diode, a one-way street for electricity. Let's quickly recap what we've learned about diodes. In the simplest terms, a diode is a semiconductor device, a tiny yet powerful component in the world of electronics. Its primary function is to allow electrical current to flow in one direction while preventing it from going the other way. This key characteristic makes it an indispensable part of countless electronic devices we use daily. In the heart of how a diode works are the concepts of forward bias and reverse bias. In forward bias, the diode allows the current to flow freely. On the other hand, in reverse bias, the diode blocks the current. Between these two states we have the depletion region, an area void of charge carriers. It's this region that helps control the flow of current, making the diode a crucial player in regulating electricity. Next time you use an electronic device, remember the humble diode, the unsung hero making it all possible.